if it's still not clear to you, why do we even need those baby steps when performing test-driven development? Today you will see why. Because today we'll work on one of the best katas to see the power of those incremental steps and continuous refactoring. So let's do it. The kata that we'll be working on today, it's the Roman numerals kata. What's the idea? You have a method, you will receive a numeral using the Arabic numeration, and then you will return the Roman numeral that corresponds to that. So examples, we can see here a few. 1, it's an I. If it's, for example, a 3 is a triple I, or for example, we have the 10 that is an X. So this might look like a simple problem. However, when we are implementing it, we'll start uncovering some interesting details. So let's put this thing in action. And the first step, it will be, and you might be thinking that it is writing a red test, but no, it's not that one. The first step is writing our test list. So let's do that. And how can you create a test list? You can grab pen and paper, use post-it notes, or even create a digital file, markdown file, text file, use your Apple Notes, Notion, Obsidian, whatever you want. I will create a test list markdown for a simple reason. I want to keep this file together in this repo, so if you, as a patron, you grab this source code, at least you have the track record of what we have done here today. Building a test list is one of the most important steps on the TDD cycle. However, in this case, I simplified our life because beforehand I created this examples list that can be the baseline for our test list. However, even then, there are some things here that look tricky, so we can take small steps here, and we'll start by writing down the things that, by looking into this, look like that they are the obvious steps that we can do now. And we can start by approaching the case of the 1 till 3, because we have here a variation of the number of highs. So we can start by saying that I, 2 the double I, and 3 the triple I, okay? And then we'll get back to our test list. Now that I have that, I need to do one thing, that is I need a test project. So let's create one. So I will name it Roman numerals tests, create a project, and before doing anything else, I will do one thing that I'll do in all of my test projects, that is installing fluent assertions. Why? Because it's small thing that you can do to improve the readability of your tests. So install that package, and I will give a proper name to the test class. And now let's write our first test. So the first case that we want to address is return I for 1. Now it's the moment where I will define the user experience of anyone trying to use this Roman numeral feature. So if I start by the end, I start thinking about the experience that I want to give without being heavily influenced by the decisions that I took before, even before getting to the place where the feature is being used. This might not be quite clear yet, but we'll see that in action. So I will start by the assert part. So you have the arrange, act, assert, 3 parts of your tests. The triple A will start by the end. And what do I want to assert? I will want to assert a Roman numeral. This is a variable that still doesn't exist. And I will say that that Roman numeral should, it's a feature of fluent assertions, be I, because it's what I'm expecting. So now I need to think, what's the correct type for this Roman numeral, okay? And I know it will be a string, but this string comes from where? And this is the moment when I'm starting to daydream the public signature that is in front of this feature. So it's the method that I'll be testing, but that doesn't mean that this method isn't calling other methods or other classes. It's not about that. It's the public interface to interact with this feature. So how do I want to expose this feature? And this could be something like saying that this is coming from 1.to Roman numeral. This would be a way to implement this by using an extension method. Or, for example, I can think about a scenario where the Roman numeral is coming from a new class that I will call, let's say, Roman numeral converter. And this class will have a method that will be the convert, let's say, okay? And the convert would receive the number. As you can see, I can start thinking about a lot of different ways of interacting with this feature. For example, I could think about a scenario where the convert is part of a static class, so I don't have to create a new class. All of those things start to emerge. And I will now take the decision of what's the experience that I want to provide. And looking at this, I really like this idea of the extension method. But let's say that I go with the converter class, so we can explore other things after. So let's throw this away. And now I took my decision and I don't want to create this here. So I will introduce a variable, and this variable will have my Roman numeral converter. And I'm calling the convert method, push this thing to the right. And this is it. I have my first failing test. I know that I haven't seen a red light, but you can treat these compilation errors as a red light. But before I address these compilation errors, there's one thing that is coming to my mind. When I look into the signature that I'm now defining, I see that I have a Roman numeral converter that will have a method named convert. And I think this is not the best idea. Why? Because one of the responsibilities of this class might be converting from Arabic numbers to Roman numerals, but also it could be the other way around. And how will that work in the future? Will it be a different overload? It receives a string, it will return a number. If it receives a number, it will return a string. It could be that, but I think it's not expressive enough for anyone consuming this class. So I will take the decision that the method will be named convert to Roman numeral. Okay? I think that this way it's a bit more clear what the code is doing. Now that I'm happy with the interface that I designed, now it's the moment to address those compilation errors. So I'll use my refactoring tools to create the class, create the method, just that, and I will keep this here for now. What do you do next? You run your tests, you see them failing. Why? This thing is throwing an exception. What's the quickest way to make this test succeed? If it is expecting an I, let's do it. We give it what it wants. We run the tests again. We see a green light. So we went from red to green. What do? We update our test list. So this first case is done. What do I want to address now? We have the 2 and the 3. So first step, I don't want to refactor now. And why I'm not refactoring now? Because you can always delay that refactoring if you see that the next iteration will give you more context of the direction that the code should go. That's one thing that I like to do. So in other words, refactoring is a step that it's extremely important. You shouldn't skip it, but you can delay it sometimes if we are talking about minutes away, not weeks away. So what we'll do now is that we need to address the case of the 2. So what we can do is that we'll go here, we create a copy. Don't worry about that for now. Should return the 2 I's for the 2, and we update the test data, run our tests. Test is failing. Why? We are returning always the I. So what can we do instead? We can check that if it's 2, we return double I. Run your tests. They are green. So, moment to refactor. And what's the first thing that you should try to understand when you are refactoring? There's anything you can do to improve clarity or duplication that you want to avoid. There are a few things that I want to do here. As an example, first one, I don't like the fact that this thing is named I, so I will rename it, run our tests, they are still green. Okay, here is everything that I want to do for now. I could move this thing away from this test class now, but I will keep it here for now, because for now it's quite useful for us that we do the first iterations and have the code here side by side. So what we'll do next, we'll look into our tests and we'll also try to find ways to improve clarity and address duplication. And it's quite clear that those two tests, have a lot of duplication. The only thing that is changing is the I here. In one you have 1, other one you have 2, and the number. So what we can do is that we can throw away one of those tests. Let's throw away this one, and we'll convert our test into a theory, and that means that we can provide inline data. So we can say that for the case that I have 2 should return double I. That means that our test method now needs 2 arguments. The first one is the number. The second one is the expected Roman numeral. So by using those 2 numbers, this means that now I can check if the Roman numeral that I get as response is equal to the expected one, and the input will be the number. We run our tests, okay? 2 tests, both of them green, and we can see here the inputs, 1 and 2. If there's anything else that we want to address here, I have some things that I want to do. For example, this can be var, and now I don't like the test name. I think I will name it should return Roman numeral for number. So now it's much better. There's other things that we can do. For example, let's first run the tests, green. The other things that we can do here, for example, we can move this instantiation to a field and we can create it there. So now when we are reading the test, we have a few things to read. So the Roman numeral converter, convert to numeral. We could even take this one step further and make this a one-liner by doing a simple thing like throwing away this, and now we can have the test like this. When the Roman numeral converter converts to Roman numeral, the number, it should be the expected Roman numeral. This is one of those cases where the functionality is so simple that having that AAA structure doesn't bring a lot of value. So you can have something simple as this, and it will be quite easy to understand what the code is doing. So we run our tests, we are still in the green state. That means that the 2 is addressed as well. So let's go to the 3, and now how can we add that test case? We go here and we say the 3 is a triple I, run your tests, 3 is failing. Go here and say 3 I's, run the test, and it's green. And we could keep going on with this approach, but you know that this is not sustainable. So what we do? Now is the moment when we start changing the code to address duplication. Okay, we are in the green state. Let's refactor this again. And in fact, we have here duplication. We know that for 2, it's 2 I's. For 3, it's 3 I's. For 1 is 1 I. So in fact, this is kind of like if we add here, if it's equal to 1, we have this thing. Imagine that this return is not here. So we have 3 lines of code doing exactly the same logic. That is basically going from 0 to the number provided and combine into a given string, a new I, and then you would return that Roman. So by doing this, this code goes away. We run our test, green, perfect. So we have the scenario of the 3 as well, but now let's keep moving forward. Let's say that I want to do the 4, but the 4, if you notice, is quite different. Is an I and a V, and if you think about the V is the 5, so it's kind of like if the Roman said that 4 is 5 minus 1. That's why the I comes first, I think, because then 6, it's V with an I. So instead of addressing now the 4, let's first go with the simple cases, that is the V, okay? If it's 5, it should return a V. So we go back into our tests and we add another one. Let's say that I want, for 5, I want a V. You run your tests. It's failing because it's returning 5 I's, okay? That was expected. So what do you do to fix this? Simple. Yeah, you know, if the number is 5, we return V. And run your tests. It goes through. So that means that the 5 is done. I don't have duplication here, so I don't have anything to address. I think it's just that. So now let's go to the 6. As I told you, let's skip the 4. So for the 6, we go to our test and we add another one. Should be the V with an I. We do the same dirty trick. We go to green. Let's go to refactoring. We have duplication. Yes. What do I have in terms of duplication here? Basically two things, that I have these two if statements, but I also have two strings that have duplication between them when they are in fact related. For example, I have here the V and the I is here and also here. So there's some relation between them. So now it's the moment to start thinking about what can we do to address this in a sustainable way, in a way that is a step forward. And since I know that 6 is the V, the 5, plus 1, and I have that part covered here, the same way that 7 will be the V plus 2, right? 2i, so 7. What I can do is that I can go here and say, okay, if the number, the Arabic number, is greater than 5, I will not return the V, I will append it to the Roman number. By doing this, and if I throw away the 6, what will happen is that for the 5 and the 6, the test will fail, and you can see that for the 5 is generating the V with 5 i's, and for the 6, same thing, but with 6. What if I used the Arabic number and I changed it to remove the number that I already processed? So if I processed 5 already, so let's subtract it. You run your tests, everything is fine. I can flag this one as done, and we can move forward. So let's pick another case before going to the 4. Let's do, for example, the 10, that is an X. How would you implement the 10? Let's go back, copy this thing, expect the X for the 10. You can see that I'm doing a lot of scroll up, scroll down. So the next refactoring chance that I have, I will extract this class to a different place. I don't want to forget that. So what you can do is that you go to your test list, and you can also take notes for refactoring opportunities. For example, I will flag here with an R, so I know that it is a refactoring move converter class. This way, I'm pretty sure that when I need, I can go back and see here, and I don't forget that. So to address the 10, what we can do, if we run our test, we should see one test failing, and it is for the 10. So what we do now is simple, the same hold if statement. For that case, return tests, everything is green. So what we do now, we'll work on this to improve it. But if I look into this, I still don't see anything worthy to replace here, right? I don't have any test failing, I don't have duplication, code is expressive enough. So what I will do is that I will bring another test case in order to discover the next step. So since I know that for the 10, we have the X, and for 12, as an example, it's an X and 2 I's. Let's bring that test case. So render test, failing. How do we do it? Same old, same old. We get to the green state. We have our safety net. So what we do, and before moving on, I forgot to flag here on test list the number 10. Now we are in the refactoring stage. Do I have duplication? Yes, I have. I have those two with a lot of duplication. So what I can do, I can apply the same recipe that you have seen here. So if it's equal to 10, instead of returning the X, what we'll do is similar of what we have here for the 5. So return the X, and we subtract the 10. We run the tests, and the tests failed, but the 10 is okay, 12 is wrong. Why? Instead of saying that this one should be greater or equal, I said equal, so that means that 12 was not going through that. What I needed to do is to change this to be for the 12 as well. So we are in the green state. Let's refactor. And what can we refactor here? Before then, let's address our node in our test list, this one. And what we'll do is that we'll extract this class out of our test class, and it's still in our test project. Can show you that here. And in the real use case, what we'll do is that we will have, let's say, another project that will be a class library, for example. Let's name it Roman numerals, and you would move that converter into that place, because now it's bothering me the fact that I need to crawl a lot to get to that test. So now that it is here, address the namespace, go back to your test cases, add the new reference, run your tests, and they are still green. So this refactoring was successful. Flag that one as done. We are still in the refactoring stage based on the addition of the 12. What we are going to do now is trying to spot duplication. And we have indeed, we have it here, we have it here. They both have the same logic. The only thing that changes is the values here, the 10 and the X based to the 5 and V. So what we need to do is that we need to create here the abstraction that will work with both. One solution that I can think about is having a data structure that will help us out. And this looks like an hash table, right? A dictionary where I see the match. For example, for 10, it should be an X, for 5, it should be a V. So let's try that way. And we can do that simply by having here a private read-only dictionary, and that dictionary will have an int and a string, call it something like symbols, and now we can add the options there. And the options that we know that we have is for the 10, we have the X, for the 5, we have the V. So this means that I can go through this symbols list and for each one execute this logic. So let's do exactly that for each symbol in symbols, and then we move this if statement into there, and we can throw this one away and simply replace the value. So the int was the key and the value was the Roman, so key as well. If we run this thing, still green, so it's working perfect. But before I close this one, let me address one thing that I don't like how it's going, that is this dictionary and the names that I gave. I don't like the fact that to access the number, I use the key, and to use the Roman value, I'm using the value on something named symbols. Also, I don't think I will take advantage of being a dictionary. So instead, what I think I will do is that I will convert this dictionary into a list, use a tuple. The int is the Arabic, the string is the Roman, and now change our options here. So the key is the Arabic, the value is the Roman. We run our tests, they are still green, and I think that the code reads better this way. Do I have anything else that I want to address for now? Don't think so. Let's mark the 12 as done. So let's put this to test and use something like the 20, that is the double X, to see if our ID is working. So for the 20, return double X, go to our tests, run the tests, okay, and that one failed. Let's see why. So it was expecting double X, but printed the X with a V and 1, 2, 3, 4, 5 I's. So that means that it went through that symbols list, but it didn't apply the 10 once again when it should, right? So I think that it's because here we apply it once, that symbol, and then we move forward, and we can't move while it's still bigger than 10, right? So if it was 21, it should still address it again. So instead of using an if statement, I think we can simply convert this to a while, run your tests, green. You start seeing that these small changes is driving to an elegant solution, but also to make these things quite obvious when we spot them. And that is what we are looking for. So the 20 is okay. Before moving on, let's think about if we need to address any duplication or something like that here, something that needs to be cleared. And I think, I'm not sure, but it's kind of like a feeling that this could also be a rule there, because I basically inverted the logic. And if I'm going through the list, first I address the X, then I address the V, that is the 5. If I have a value below V, I can apply the I until I get to the point that I want. The way that I'm seeing now is that, imagine I have 5. It goes to the 10, doesn't match. It goes to the 5, returns the V, subtract 5, it's 0, we stop here, we return. Now imagine that is for example, the 3 doesn't match the 10, doesn't match the 5. It goes to our for loop. What if we have here that 1 as the symbol I? So that way it will go with the 3, doesn't match the 10, doesn't match the 5, it matches the 1. So if it matches the 1, let's go to this while 3 is bigger than 1, let's add an I and let's subtract 1. Then it will be 2. Let's add another I, let's subtract 1. Now it will be 1. Let's add another I and we'll have the triple I's. So if we do this, I think we confidently can change this. And why I'm doing this? Because I have an excellent safety net with a lot of tests. So, perfect. Still green. So we simplified a lot our solution, and you can see that the design of this code emerged by the fact that we start bringing one test case at a time and improving solution. So 20 is addressed as well. If we go back to our kata, I think now we can think about that 4. And one way that I believe we can do this is by treating these exceptions as symbols itself, right? Instead of adding the V here, why not adding them directly here? So let's try it. We'll add the 4. Let's add this thing in order. And if we add the 4 here as well, before that, let's run to see the test failing. I don't trust tests that I've never seen the red light. So we have the failing test. What we do now, 4, run the test. It's green. Why does it work? It goes through the symbols. It's not bigger than 5 or equal, so it goes to the next one. Is the 4. Let's append the symbol IV, subtract 4, now it's 0. We end everything. So it works, so we can mark the 4 as done. The fact that we delayed the tricky cases to the end, it made that we basically simplified the solution, because the solution emerged by the fact that we implemented the rest in this way. So let's go to our kata and find some more tricky cases we can solve. For example, let's add them to the test list. 9 should be IX. We have these ones, the bigger ones, we can add them as well. So what we do, let's take care of the 9. 9 comes before 10, so IX, 9. How do we take care of that one? Let's apply the same recipe. It's a 9x. Run your tests. They are green. That's perfect. 9 is done. Let's take care of the other ones. Now that we know that we have a solution for anything, let's quickly add them here. So 50, 100, 500, 900, and 1000. Run our tests. Okay, we have the 50, 500, 900, 100, and 1000. That matches the number of tests that we had. So let's go to our table that is helping us, that list, and we simply need to add them here in the reverse order. So 1000 is the M. So now we run our tests and they are all green. Just to make sure that everything is working, let's go to a random number generator, here random.org. Let's say that we want a number between 1 and 1000. Let's generate one of them, 857. Let's say the test case for that. So, how's the Roman number for 805? So, it's 5 plus 300, so it should be 3 C's. So, 100 is C, so C, C, C. Then we go to the 50. 50 is an L. 7 is the V, and 2 I's. Okay. I think it's that. Let's run the tests and find out. Awesome. So all of our test cases are done. So we came to the end of this kata, and one thing you can be sure is that there are many ways to address this problem, and at any given point we could have take a different path and achieve a different solution. However, the simple fact that we have used TDD here, small steps, continuous refactoring, it made us to come up with this solution that is quite elegant in my opinion and easy to read. I hope that with this video it became clear to you this process of TDD and why it's so important to continuous refactoring your source code. And if you want to see more TDD in practice, make sure you watch this video right here.